Hello, class. I received a question on figuring out the polynomial that has 4 minus 3i and 4 plus 3i as solutions. The multiplication with this particular problem does get a little bit icky, and so I want to go back and really kind of talk about how we do this and why we do this and how it works, so that you can get a better understanding on exactly what's happening here, and it will help you be able to solve it. So what we know about complex conjugates is that they travel in pairs. So if I have 4 minus 3i as a solution to a polynomial, I have to have its complex conjugate as a solution. And the complex conjugate is 4 plus 3i. So that is the solution. 4 minus 3i and 4 plus 3i are the solutions. Now, if I'm talking about a factor, I'm going to take each one of these solutions and to put it into factored form, that is when I have the x minus. So I have x minus 4 minus 3i and x minus 4 plus 3i. So that is the factor that is associated with the solutions of 4 minus 3i and 4 plus 3i. So we have our solutions and then we have our factors. So just a little side note, think about this. If I tell you that my solution is 4, that means my parabola or my polynomial crosses the x-axis at 4. My factor that is associated with that is x minus 4. So I have a solution and then I have a factor associated with that. And so that is what is happening here. We have solutions and we are developing the factors that are associated with those solutions. So we are going to multiply this out, but first let's multiply out something that's a little simpler. So if I tell you that 3i is a solution, it has to travel in pairs. It has to have its conjugate. So its conjugate is negative 3i. Okay? So I'm telling you that 3i is a solution. You need to find the other solutions, which is negative 3i, and then we're going to find the polynomial associated with this. So if 3i and negative 3i are the solutions, x minus 3i and x minus negative 3i are the factors. And that's what I multiply together to get my polynomial. So I'm going to rewrite this as x minus 3i times x plus 3i. Okay, at this point we FOIL. X times x is x squared. X times positive 3i is positive 3ix. Negative 3i times x is minus 3ix. Negative 3i times positive 3i is negative 9i squared. Okay, we want those middle terms to cancel out. So 3ix and negative 3ix, they cancel out. That's what we want to happen. So we are left with x squared minus 9i squared. And I squared is negative 1. So I have x squared minus 9 times negative 1. So that leaves me with x squared plus 9. So x squared plus 9 is my function that has solutions of 3i and negative 3i. So what I just did over here in the blue, that's what I'm wanting to do with complex solutions that are 4 minus 3i and 4 plus 3i. So what I have to do is I have to multiply this out. Now, the difficult part of multiplying x minus 4 minus 3i and x minus 4 plus 3i is what we have as a trinomial multiplied by a trinomial. And that means that my x has to go to everything in the second trinomial, my 4 has to go to everything in my negative 3i. Because we understand the properties of this, we can make it simpler. We can solve it very similar to the way that we solved this over here because we understand the properties of these conjugates. Now, could you distribute the negative and multiply the trinomial times the trinomial using the distributive property? Yes, you could. But if we understand what's happening here, using the FOIL and thinking of 4 minus 3i and 4 plus 3i as a unit, and that's what we're going to think about. We're going to think about it as a unit. It's sticking together. Then the problem is a little bit simpler to solve. So I'm going to try to use some different colors to show you how to do that. So the first thing that I'm going to do is, and I'm using FOIL. So I am going to multiply my x times my x. And when I multiply my x times my x, I get x squared. Okay? Now what I'm going to do is I'm going to multiply my x, and I'm going to multiply that times negative 4 plus 3i. I am thinking about this 4 plus 3i as a unit. So I am going to have minus x times 4 plus 3i. So I have dealt with the outer terms. I have multiplied my outer term of x times my outer term of negative 4 plus 3i. Okay, now I'm going to deal with my inner terms. Okay, so I've got minus 4 minus 3i, and I'm going to multiply that times x. Okay, so I'm going to write my x, and that's going to be negative because our x minus. Okay, so I am going to write down negative x, and I have got that times 4 minus 3i. Okay, so what I've done there is I have taken this as an inner term, and I have multiplied it times this inner term. Okay, now I am going to multiply my last. Now, if you look, I have a negative and a negative. That is going to make it a positive. Okay, then I have 4 minus 3i, and I am multiplying that times 4 plus 3i. So this is what I'm multiplying. This is my last, and this is my last. And I'm running out of room, so I'm going to erase so that we can see this. Okay. Okay. Now, you want to take, so we have foiled this. We haven't done a trinomial times a trinomial. We have foiled it, and we have looked at this conjugates, these two conjugates, as a term together. That's what we've done. So now what I'm going to do is I am going to distribute, and I'm going to FOIL. So I'm left with x squared. Okay, now I'm distributing here. So I have negative 4x, and I am left with negative 3ix. Okay, I distribute again, and I am left with negative 4x, and I am left with positive 3ix. Okay, now here I have my complex conjugates, and I'm going to multiply them together using FOIL. So because I have a binomial times a binomial, I'm using FOIL here. Okay, 4 times 4 is 16. 4 times negative 3i is negative 12i. And that second binomial is plus 3i right there. That should be plus 3i. Okay, and that's how we want it. So I've got 4 times 4 is 16. 4 times positive 3i is positive 12i. Negative 3i times 4 is negative 12i, and that's what we're looking for. We want to cancel those out. Then I've got negative 3i times positive 3i. That's going to give me negative 9i squared. Now we're in a situation where we can cancel out, and lots of our i's are going to cancel out. So I'm left with negative 3ix here, positive 3ix here, positive 12i here, and negative 12i there. If your i's do not cancel out, you have made a mistake and you need to go back and look at it. Okay? So now I'm left with x squared minus 8x. Okay? Then I have plus 16 minus 9i squared. And we know that I squared is negative 1. Okay, so then I have negative 9 times negative 1, so I end up with positive 9 right there. And when I add those two like terms, my final answer to this is x squared minus 8x plus 25. This is the polynomial that has 4 minus 3i and 4 plus 3i as solutions. I'm working backwards. We're used to saying, find the solutions of x squared minus 8x plus 25. But what's happened here is I've given you the solutions and you work to find the polynomial that has those solutions, okay? The algebra gets very icky here because you've got a trinomial times a trinomial. Now, you could multiply x and treat it as a trinomial times a trinomial. And sometimes when students don't fully understand the FOIL process here, that's what they do. There's lots and lots and lots of opportunity for mistakes. And you can notice here, I missed a sign right here. Okay, and I knew that I needed to go back because those were complex conjugates, and I knew that I had to have a plus there. So when you are multiplying this out, there's lots and lots of opportunity for algebraic mistakes, so be super careful with that. Now, I want to go ahead and check this so that I can show you how to check it, just so you can see what's happened here. So I'm going to move on to my next screen. My final answer to this was x squared minus 8x plus 25. And so this is the function, or the polynomial function, with rational coefficients that has 4 plus 3i and 4 minus 3i as solutions. So think about this right here. Now, if we were solving this, and that's what we've done first, if we were solving this, this actually lends itself to completing the square pretty nicely. So I'm going to rewrite this as x squared minus 8x plus 25. And I'm going to do completing the square. So I have x squared minus 8x, and I'm going to move that 25 over, so I have negative 25. When I'm completing the square, I take half of my b value, so half of negative 8 is negative 4, and I square that. So negative 4 squared is 16, and so I add 16 to both sides. I factor the left-hand side. So I have x minus 4 squared, and I simplify the right-hand side, and I'm left with negative 9. I take the square root of both sides, and when I take the square root of the right-hand side, I have to put the plus or minus. So I am left with x minus 4 equals plus or minus the square root of negative 9. Okay, the square root of negative 9 is 3i, so I have plus or minus 3i, x minus 4. I add 4 to both sides, and my final answer here is x equals 4 plus or minus 3i. So what you were asked to do on the problem before this is you started here, and you worked back to our polynomial. Okay? So when you are given two conjugates or two complex numbers, or you're given one complex number and you've got to find the other one and then find the polynomial, this is how you do it. Remember that this is a solution, and so you've got to go from solution to factor, And then once you've got your factors, and that's what x minus 4 minus 3i and x minus 4 plus 3i are. These were your factors. And then you multiply your factors together to get back to the original polynomial. So it is working a little bit different. Don't hesitate to reach out and let me know if you have other questions about that. This is one of the more difficult algebraic processes, so don't let this scare you too much.